Hello students and welcome back to my channel. This is the fourth video in continuation with the remaining three videos. In this video, we will be discussing questions which were asked on the basis of gravitation and rotational motion. Okay, these questions were asked on the 27th January 2024 JEEN mains. So without wasting time, let us discuss them one by one. So coming to the question number 14, you can see the acceleration due to gravity on the surface of Earth is g. If the diameter of Earth is reduced to half of its original value, the mass remains constant, then acceleration due to gravity. So this is very simple question, students. There is nothing new in this. As you know that on the surface, the acceleration due to gravity due to any spherical body for that matter is gm by r square. So it is given that the diameter reduces to half. So naturally radius would also reduce to half. So mass remains constant. So we can write g varies inversely as the square of radius. Okay students. So here we can see radius reduces by half. So just put the factor of change in the place of r here. You will be getting the factor of change for g. So g becomes 4 times of original g. So this is how you are supposed to solve, students, in the exam hall. Okay. Because time is the most important resource in the exam hall. Many students I have seen in my career who had a profound knowledge, tremendous knowledge, but they failed in IITs and all just because they couldn't manage their time. So time management is also equally important as the knowledge is. Okay students. So this is how you are supposed to handle these kind of questions here. What I did, again I will repeat, students, see here. I have just put the factor of change for radius in the place of r. Here factor of change for radius is half. So I put half here in the place of r. So 1 upon half square is 4. You get the factor of change for g. And the final value of g is always initial value into factor of change. Right. Moving to the next question, students. Given below are two statements. One is labeled assertion and the other is reason. We can see. The angular speed of the moon in its orbit about the earth is more than the angular speed of the earth in its orbit about the sun. This is true, students, because how do you calculate angular speed? It is distance, angular displacement in one rotation upon period of rotation. So for the moon period of rotation is around 27 days, slightly less than 1 month. Whereas for Earth, it is around 365 1 by 4 days. So naturally, the period of revolution for Moon is less. So angular speed will be more for Moon. This is true. Coming to reason, the Moon takes less time to move around the Earth than the time taken by Earth. This is also correct, students. Probably you can see omega varies inversely as t. So for Moon, t is less, so omega is more. So both A and B are correct and R is the correct explanation also. Coming to question number 16. A heavy iron bar of weight 12 kg is having its one end on the ground and other on the shoulder of a man. The rod makes an angle 60 degree with the horizontal. The weight expressed by the. So even though they are asking weight, students, we can see the units are kgs. Okay. In other words, they are asking weight in terms of kg weight. So let us draw a rough diagram here. So this is the iron bar. Okay, we can take this as hinge A, and the person's shoulder is here. Okay, the person's shoulder is here, and this way. So definitely the reaction offered will always be perpendicular to the surface. Very important, very important. So the reaction force is what is being asked. Because what will be the weight experienced by the person? Simply, naturally, whatever reaction his shoulder is offering to the rod, that is the weight. You can call it as apparent weight as experienced by the person. So this is what is being asked. So the rod is how much long? Maybe I'll take this as we don't require that actually. And here, since it's assuming the rod to be uniform, the weight, that is 12 into g, will be acting exactly at the midpoint. This is the midpoint, this is the center of mass. Okay, so no need to draw the forces here because anyway they will get cancelled here. Okay, students, the torque due to these forces will be 0. We are going to take the torque about point A. Torque due to these two forces will be 0. So you have a clockwise torque offered by the weight, which will be offset or balanced by the anti-clockwise torque offered by the normal reaction. So we are basically applying principle of moments. So as per principle of moments, for the rotational equilibrium of a rod or anything for that matter, clockwise moments should balance the anti-clockwise moments. Clockwise moments should balance the anti-clockwise moments. So here the clockwise moment offered is 12 kg into G, that is due to the weight, into, this is the lever arm, students, this is the lever arm. If you take this angle as 60 degree, what they have given, so this will be L by 2 cos 60. You can see L by 2 cos 60. So L by 2 cos 60 degree. Whereas reaction force we have to find, and the lever arm for the reaction force is clear cut L. So therefore R is equal to 3 kg weight. 3 kg weight. So 3 is the correct answer, students. Okay. Then moving on to section B. You know, students, section B questions, they are fill up the blanks kind of questions. You don't get options there. Straight away you have to bubble the numbers, numerical questions without any options. Now, 4 particles of mass 1 kg each are placed at 4 corners of a square of side 2 meter. Moment of motion of the system about an axis perpendicular to its plane and passing through one of its vertex. So you can take the square like this, something like this. So these are the particles, and the axis is perpendicular to the plane. This way, this is the axis. So there is no moment of inertia due to this, because it lies on the axis itself. So you have m into 2 square. Here also m into 2 square, and here you have m into 2 root 2 square, because the length of the diagram will be 2 root 2. So the required moment, total moment of inertia will be due to this. Remember, mass is 1 kg. So 1 into 2 square plus due to this again 1 into 2 square plus due to this 1 into 2 root 2 square. So 4 plus 4 plus 8, that is 16 kg meter square. So 16 is the correct answer. Moving to the next question. Question number 18. A ring and a solid sphere roll down the same inclined plane without slipping. They start from rest. The radii of both are identical. Ratio of kinetic energies. Now this is based on very fundamental concept, students. As you know that when a rolling body comes down, okay, when a body is rolling without slipping, so you know the point of contact of the body with the inclined plane is at instantaneous rest. Instantaneous rest. That means no work is done against the friction. Okay, no work is done against the friction. So that in other words, there is no energy loss as it moves from top to bottom. So during the course of motion, if there is no energy loss, you can apply the law of conservation of energy. So since both of them are descending the same inclined plane, so you can see the height lost by both of them will be same. So kinetic energy gained will be mgh. Of course, this kinetic energy will be in the form of translatory kinetic energy and rotatory kinetic energy. So you can see their masses are same. Okay, their a ring and a solid sphere roll down the same inclined plane without slipping. Somewhere it has to be mentioned, students, that they carry the same mass. Okay. So therefore the ratio of their kinetic energies will be 1:1. So 7:x. So x has to be 7. A ring and a solid sphere of same mass. Mass must be same. Okay, because the energy gained will be dependent only on the energy lost, and the energy lost is same. That's all students in this video. Thank you so much for watching.